Imagine a world where every horizon stretches endlessly, unbroken by mountains, oceans, or human boundaries, a world where the land itself pulses with the rhythm of life, and the air carries stories older than time itself. What if Earth was a test-stand experiment in survival, in resilience, in the unfolding of life's grand possibilities? To walk upon this world would be to step into a living narrative, where every gust of wind, every ripple of water, and every rustle of foliage tells a story of adaptation, endurance, and the relentless passage of time. Long before humans drew borders across continents, long before civilizations rose and fell, the Earth was a single, unbroken canvas. It was a supercontinent, a vast expanse of land known as Pangaea, where ecosystems intertwined in intricate and unexpected ways. Rivers carved deep into the rock, carrying with them the minerals of the mountains to nourish distant lands. Forests stretched from the coasts to the interior, their trees whispering in the wind, their roots binding the soil and stabilizing the land. Deserts sprawled across the heart of this great continent, waiting in silent patience, challenging life to adapt, evolve, and persist. If you had stood upon one of Pangaea's rivers, you might have witnessed life in abundance. Herds of plant eating synapsids grazed in the shallows, their movements slow and deliberate, yet purposeful. Predators moved with careful stealth along the riverbanks, watching, waiting for the right moment to strike. Amphibians slipped silently into the water, while insects rose in clouds from reeds and fallen vegetation. Every footstep, every flutter, every ripple was part of a delicate dance, a network of life sustained by the rhythms of water, wind, and sunlight. The rivers themselves were far more than flowing water. They were the veins of a supercontinent, carrying life from one end to the other. As they descended from high mountain ranges, born of tectonic upheaval, they gathered strength from countless tributaries, becoming sweeping arteries of nourishment and migration. Their floodplains were lush corridors of green, a stark contrast to the drier interiors, where seasonal rivers could mean the difference between survival and desolation. These waterways connected distant ecosystems, allowing species to spread across the vast landmass, introducing competition, collaboration, and adaptation into the evolutionary equation. Above Pangaea, the sky was alive. Winds swept across the continent, uninterrupted by the barriers that today define our weather patterns. They carried moisture from distant oceans into arid interiors, bending the crowns of towering conifers and brushing against the leaves of seed ferns. During monsoon seasons, these winds swelled, pulling massive volumes of water from the seas, drumming it across rivers and floodplains, saturating soils, and igniting bursts of life. The air vibrated with the calls of creatures large and small, from the deep growls of predators to the subtle hum of insects in the undergrowth. Each storm, each breeze, each whisper of wind was part of the ongoing dialogue between the earth and the life it harbored. Yet, Pangaea was not a world of uniform abundance. Its interior deserts tested the limits of adaptation. Here, ephemeral streams and temporary pools offered fleeting salvation. Creatures that ventured into these regions had to be resilient, efficient, and cunning. Small synapsids, early reptiles, and amphibians mastered these harsh environments, their survival dependent on their ability to exploit every resource, to hide from predators, and to endure the extremes of climate. Even in scarcity, life found a way, teaching lessons of persistence that would echo through millions of years. The concept of Earth as a test extends not only to the survival of species, but also to the very processes that shaped its surface. Tectonic forces lifted mountains, opened valleys, and created rift zones that would one day split the supercontinent. Volcanic eruptions poured lava and gases into the atmosphere, transforming climates, challenging ecosystems, and driving evolution forward. Storms of unimaginable scale reshaped coastlines, while gentle winds transported seeds, spores, and dust across continents, subtly knitting the world together into a complex system of interdependence. Every mountain, river, and valley was both a barrier and a bridge, shaping life in ways both dramatic and subtle. If Earth was indeed a test, then Pangaea was its first examination. It offered a single stage upon which life could experiment, adapt, and diversify. Species that survived the challenges of this ancient world carried forward not just their genes, but lessons in endurance, flexibility, and the ability to navigate a planet in motion. Every creature, from the smallest insect to the largest synapsid, played a role in this grand experiment. Their interactions, migrations, and survival strategies set the stage for the evolutionary dramas that would follow for hundreds of millions of years. As you listen to this story, Imagine standing upon a hilltop, gazing across a landscape unbroken by oceans. The horizon stretches far and wide, interrupted only by the occasional rise of a mountain or the curve of a river. Birds, insects, and early reptiles move through the air and undergrowth, their lives entwined with the rhythms of water and wind. You feel the weight of the sky above, the heat of the sun, and the subtle shifts in air pressure that signal approaching storms. This is a world of extremes and balance, of quiet endurance and dramatic change, where life constantly tests itself against the forces of nature. Even the soil beneath your feet carries a story. Layers of sediment deposited over millennia tell of floods, droughts, and the shifting courses of rivers. Fossils embedded within these rocks bear silent witness to the countless generations that came before, each adapting, surviving, and passing on the legacy of life's resilience. To study these layers is to read the chronicles of Earth's first test, to trace the patterns of adaptation, migration, and survival that laid the foundation for the diversity of life we see today. Pangaea, in its vastness, also foreshadowed the challenges of isolation and division. While it was united as a single landmass, subtle rifts and climate gradients created pockets of ecological pressure, encouraging species to adapt in localized ways. These early divisions would become more pronounced as tectonic forces eventually split the supercontinent. But even in its unity, the seeds of evolutionary divergence were sown. Life on Pangaea was already learning the lessons of connection and separation, cooperation and competition, abundance and scarcity. The great rivers, the winds, and the seasonal monsoons were not merely environmental factors. They were teachers, testing every organism in the crucible of survival. Life learned to move with the seasons, to exploit transient resources, to navigate corridors of connectivity, and to endure the harshest conditions. These lessons were written not in words but in the genetic codes, behaviors, and adaptations that would persist through the ages, guiding future lineages through their own tests of endurance. And so, we begin our journey into this world, a world where Earth itself seems to ask, can life endure? Can it adapt, survive, and flourish against unimaginable odds? Through rivers and deserts, forests and mountains, storms and winds, the first great test unfolds. As we explore the rise and fall of species, the shaping of landscapes, and the rhythms of the sky, we come to understand the magnitude of what it means for Earth to be a relentless, patient, and beautiful experiment in life itself. From the earliest moments of Pangaea's formation to the tumultuous events of mass extinctions, from the slow drift of continents to the emergence of new ecosystems, this is the story of Earth as a test. A story that stretches across millions of years, spanning continents, climates, and countless generations of life. It is a narrative of struggle and survival, of adaptation and transformation, and ultimately, of the enduring resilience of life in the face of constant change. Long before life crawled onto the shores or plants stretched toward the sky, the Earth itself was in motion, a molten sphere sculpted by cosmic forces beyond comprehension. To witness its formation would be to watch a world being forged in fire, collisions, and gravity's relentless pull. Every mountain, every valley, and every ocean basin we see today was once a story written in rock and magma, a narrative of chaos gradually giving way to structure. Billions of years ago, Earth existed as a turbulent planet, its surface a roiling sea of lava punctuated by molten storms and volcanic eruptions that lit the young sky. The atmosphere was heavy with gases, sulfur, and steam, creating a greenhouse blanket that trapped heat and shaped the earliest climates. Through this chaos, gravity pulled together fragments of matter, dust, rock, and metal coalescing to form the solid crust that would cradle future life. With each collision and accretion, the Earth grew heavier, denser, and more complex, its interior stratifying into layers of core, mantle, and crust, each playing its own role in the planet's future evolution. Amid this turmoil, water emerged, ice from distant comets, condensation from volcanic outgassing, and early precipitation began to fill basins, forming primordial oceans. These bodies of water became Earth's earliest sculptors, eroding volcanic rock, carrying minerals, and shaping the landscapes into valleys and ridges that would one day host rivers, forests, and deserts. Imagine standing on the edge of such an ocean, waves lapping against jagged basalt cliffs, steam rising from fissures in the crust, and the air thick with the smell of sulfur and salt. Even in these earliest moments, Earth was a living, dynamic entity. Tectonic forces, unseen yet inexorable, began their work. Beneath the surface, convection currents in the mantle slowly pushed and pulled the crust, driving the birth of continents. Land masses collided, fused, and rifted apart in cycles that would repeat over eons. These tectonic dances gave rise to mountain ranges, deep valleys, and the first supercontinents, including the ancient Pangaea. Rocks twisted, folded, and fractured under immense pressure, their mineral compositions reflecting the violence and beauty of the processes that formed them. Each collision was a test, a crucible in which Earth's future landscapes were forged. With the formation of continents came diversity in the land itself. High mountains captured snow and rain, feeding rivers that carved deep canyons and spread life-giving sediments across the plains. Deserts formed in rain shadows, testing the adaptability of future organisms. Coastal regions, constantly reshaped by waves and tides, became nurseries for marine life and provided corridors for early migrations. Across these landscapes, the Earth was simultaneously harsh and nurturing, a world of extremes that demanded resilience from every emerging life form. Volcanoes punctuated the young continents, their eruptions both destructive and creative. Lava flows covered the land, building new rock layers while obliterating existing habitats. Ash clouds darkened skies for weeks, shifting climates and altering weather patterns. Yet these fiery events also enriched soils, providing minerals that would nourish future forests, plains, and river valleys. Life, when it arrived, would learn to thrive in the aftermath of destruction, finding opportunity in chaos and stability in the very instability of the planet itself. Water and wind worked in tandem, with tectonic activity to shape the face of Earth. Rivers cut channels through rock, meandering across continents and leaving fertile floodplains that would one day teem with plants and animals. Winds transported dust and spores, connecting distant ecosystems and fertilizing regions far from their origin. Storms and monsoons became architects of the climate, driving the ebb and flow of life across Pangaea's vast reaches. Each element, earth, water, air, fire, acted as both sculptor and teacher, challenging the organisms that would eventually inherit the planet. The continents themselves were far from static. Rift valleys opened, splitting land masses and creating isolated habitats. Over millions of years, these divisions would lead to speciation, allowing life to adapt uniquely to local conditions. But even as separation occurred, rivers, wind patterns, and climatic corridors maintained connections, ensuring that no organism existed entirely in isolation. The interplay of unity and division, of connection and separation, was a central theme in Earth's great experiment. Beneath the surface, the Earth's mantle was alive with energy. Magma surged upward along faults and fissures, occasionally breaking through to create volcanoes or fill new ocean basins. These eruptions shaped coastlines, redirected rivers, and influenced atmospheric composition. Imagine standing on the edge of a freshly formed basalt plateau, the heat radiating beneath your feet, the sky tinted orange by volcanic gases, and the distant rumble of the Earth's interior, a constant reminder of the planet's restless energy. Life, when it emerged, would inherit this dynamic, ever-changing world, learning to endure its trials and exploit its opportunities. By the time Pangaea fully assembled, the Earth had become a stage ready for life. Mountains towered over plains and deserts, rivers carved green arteries through the land, and coasts lapped against oceans rich with nutrients. The planet's atmosphere had stabilized enough to support life, yet remained volatile enough to challenge and shape it. Each region offered its own tests. Arid interiors demanded conservation and resilience. Fertile plains encouraged growth and abundance. Coastal zones offered both opportunity and danger. Life's journey was inseparable from the Earth's narrative, each shaping and responding to the other. Through this immense period of formation, the Earth taught its first lessons. Life, when it emerged, would have to navigate extremes, move across vast distances, and adapt to shifting landscapes. The rules were being written not in textbooks but in stone, water, and air. Every mountain range, every river valley, every wind-blown dune was a chapter in the planet's ongoing story, an invitation to life to meet its challenges. Survival would not be guaranteed. Adaptation would be essential, and endurance would become the measure of success. In this world, time was a river itself, flowing over millions of years, shaping rocks, climates, and the very possibilities of life. Erosion and deposition, uplift and subsidence, flooding and drought, all were forces testing the Earth's systems, and the future inhabitants they would sustain. The supercontinent was both arena and teacher, a single stage upon which the drama of life would unfold. For those first creatures, the Earth was the ultimate test, demanding intelligence, flexibility, and resilience in ways that would define evolutionary success for eons to come. As we look back on these formative eras, it becomes clear that the Earth itself was an experiment, a vast, dynamic, and interconnected system that tested life even before it existed. The continents' assembly, the shaping of rivers and mountains, the rhythms of climate and wind all contributed to a world prepared to challenge, nurture, and ultimately sustain life. From the chaos of formation emerged the stage for one of the greatest tests in the history of our planet: survival, adaptation, and evolution across Pangaea. As the continent stabilized, the Earth's surface became a canvas painted with rivers, deserts, and fertile valleys. Water, the lifeblood of the planet, carved channels through mountains, widened plains, and fed the first ecosystems. The great rivers of the supercontinent flowed with relentless determination, their sources high in volcanic peaks and snowy uplands. Snowmelt and rainfall gathered strength, joining countless streams to create sweeping waterways that stretched across vast plains and forests. These rivers were not merely channels of water, they were arteries of life, carrying nutrients, minerals, and sediments that would nourish every corner of Pangaea. The riverbanks teemed with activity. Imagine standing on the edge of a shallow floodplain, the air thick with humidity, insects buzzing in clouds above the reeds, and the faint scent of wet earth and vegetation filling your senses. Amphibians slithered through the mud, hunting for insects or hiding from predators. Small reptiles darted across the banks, alert to every rustle in the undergrowth. Herds of synapsids, early mammal-like reptiles, moved along the river courses, feeding on lush vegetation while predators lurked in the shadows, waiting for an opportune strike. Each river became a corridor of life, linking distant regions, supporting migrations, and fostering interactions that would shape evolution for millions of years. Beyond the rivers, deserts spread across the interior of the supercontinent. These were not the endless sands of the modern Sahara, but vast, challenging landscapes where survival required adaptation. Dry winds swept across rocky plains, lifting dust and scattering seeds across long distances. Pools formed only after rare storms, ephemeral oases that became hubs of activity. Creatures converged here to drink, feed, and rest, leaving traces of their presence pressed into drying mud. Fossils from these ancient floodplains bear witness to a tapestry of life that endured, adapted, and thrived even in scarcity. The deserts and rivers created contrasting environments that tested life's resilience. On one side, fertile plains and floodplains encouraged abundance and growth. On the other, arid interiors demanded conservation and adaptability. Plants evolved to survive these extremes. Tough conifers, seed ferns, and cycads dominated the landscape, their roots stabilizing soil and their seeds carried by wind across vast distances. Insects proliferated, taking advantage of the diverse flora, while amphibians and reptiles adapted to the rhythms of water and drought. Every creature was part of a vast, interconnected web, each dependent on rivers, rainfall, and the shifting landscape. Seasonal changes added another layer of complexity. Monsoons swept across the coasts and into the interior, swelling rivers, flooding plains, and rejuvenating ecosystems. During these rains, the world transformed. Dry valleys became rivers of life. Insects filled the air, amphibians emerged from hiding, and plants flourished with renewed vigor. When the rains ended, the floodwaters receded, leaving fertile silt that nourished plants for months. Life adapted to these cycles, learning to thrive in abundance and endure scarcity, a rhythm dictated by the forces of Earth itself. Even the quietest streams played a role. In the drier interior, ephemeral waterways became lifelines. Small creatures depended on these brief floods for survival, moving between temporary pools and leaving tracks that would become fossilized evidence of their existence. Predators learned to exploit these gatherings, stalking prey at the edges of these fleeting oases. In this delicate balance, survival depended on timing, adaptability, and awareness of the environment. Rivers, deserts, and ecosystems did not exist in isolation. Wind carried dust and spores across continents, enriching distant soils. Volcanic eruptions deposited ash, fertilizing lands far from their source. The atmosphere itself was a participant, with winds and storms shaping landscapes, distributing seeds, and influencing climate. This interconnectedness created a supercontinent in which every ecosystem influenced the others, and life adapted to a dynamic, ever-changing stage. The diversity of life along rivers and deserts foreshadowed the evolutionary experiments to come. Small, resilient creatures survived harsh climates and competition, laying the groundwork for the rise of larger, more specialized organisms. Predators and herbivores, aquatic and terrestrial species, all interacted in ways that reinforced the rhythms of the planet. The Earth itself became a laboratory, testing adaptation, endurance, and the capacity for life to flourish under extremes. By understanding these early ecosystems, we glimpsed the challenges that shaped life on Earth. Rivers brought abundance and connectivity. Deserts tested resilience. Floodplains offered both danger and opportunity. Together, these landscapes formed a living network, a system in which every drop of water, every gust of wind, and every grain of dust contributed to the story of life. Life on Pangaea was not passive, it was active, responsive, and deeply intertwined with the planet's rhythms. In this way, the supercontinent prepared life for the trials of extinction, climatic change, and tectonic shifts to come. The first ecosystems were arenas of competition, collaboration, and survival, each species learning to exploit its niche while adapting to the unpredictable forces of Earth. Rivers and deserts were both teachers and arbiters, shaping behaviors, physiologies, and strategies that would resonate across evolutionary time. As we visualize these landscapes, we begin to understand the magnitude of Earth's early experiments. Rivers meandered endlessly, deserts stretched beyond the horizon, and life responded with ingenuity and resilience. From the smallest insect to the largest synapsid, each organism participated in a complex dance orchestrated by geology, hydrology, and climate. These early ecosystems were not merely settings, they were active participants in the shaping of life's future. Above the vast landscapes of Pangaea, the sky spoke a language of its own. Winds traveled unimpeded across immense distances, carrying moisture from the oceans to the heart of the supercontinent, shaping forests, deserts, and river systems alike. With nearly all landmass gathered into one contiguous expanse, the atmosphere became a powerful, unbroken force, and the weather patterns reflected this unique geography. Air currents that began over Panthalassa, the surrounding superocean, could sweep thousands of kilometers inland, bringing storms, floods, and tempests to regions far from the coast. Imagine standing in the dense coastal forests as a monsoon arrives. The sky darkens with heavy clouds, the scent of rain fills the air, and every leaf, branch, and blade of grass trembles under the weight of the wind. Rivers swell beyond their usual banks, and floodplains transform into temporary lakes bustling with activity. Amphibians emerge from their burrows, insects rise in swarming clouds, and reptiles patrol the edges of these newly formed waterways. The rhythm of life is orchestrated by the weather itself, a natural symphony of wind, rain, and motion. Further inland, the winds become drier and hotter, hissing across deserts and barren plains. Dust storms rise from the surface, carrying fine particles over hundreds of kilometers, enriching distant soils and fertilizing ecosystems far from the point of origin. These arid winds shape not only the land, but also the creatures that live upon it. Animals and plants alike adapted to extremes of heat, scarcity, and unpredictability. The interior deserts of Pangaea were arenas of endurance, where only the resilient survived, and each gust of wind was both a challenge and a guide. Thunderstorms were another voice in this ancient sky. Towering cumulonimbus clouds could reach into the stratosphere, lightning splitting the air in brilliant flashes, followed by rumbles of thunder that echoed for miles. Near the coasts, these storms could bring torrents of rain, refilling rivers and floodplains, while farther inland, their clouds often passed without delivering more than a few drops, emphasizing the distance from the oceans. The contrast between the moist, fertile regions and the dry interior created complex ecosystems, each adapted to its local climate, but all interconnected by the overarching patterns of wind and rain. Volcanoes also contributed to this atmospheric orchestra. Along tectonic rift zones, eruptions sent ash and gases high into the air, sometimes dimming the sun for days and creating localized climate disruptions. Lightning danced through volcanic plumes, adding a fiery dimension to storms, while ashfall fertilized soils hundreds of kilometers away. Life adapted to these periodic upheavals, and ecosystems learned to recover, often stronger and more diverse after the disturbances. Seasonal changes dictated life cycles. The monsoons arrived with predictable intensity, followed by dry seasons where rivers shrank and floodplains dried. Migratory patterns, feeding habits, and reproductive cycles all synchronized with these rhythms. The wind was more than a passive element, it was a force that carried seeds, spores, and even small animals across distances, ensuring genetic diversity and connectivity. Insects traveled on air currents, plants spread their offspring far and wide, and even small reptiles found new territories thanks to the wind's invisible pathways. These atmospheric forces shaped evolution itself. Life forms developed adaptations to cope with strong winds, heavy rains, and scorching heat. Conifers and seed ferns grew needle-like leaves to reduce water loss. Insects evolved wings capable of long-distance travel, and amphibians developed behaviors to exploit fleeting water sources. In the deserts, tough-skinned reptiles and drought-resistant plants learned to thrive where rainfall was rare, and ephemeral water holes became oases of survival. Every organism was a participant in the grand dialogue between the Earth's surface and its sky. The interplay of climate, storms, and winds also influenced migration. Herds of early synapsids, reptiles, and other vertebrates moved seasonally in response to shifting resources. The wind dictated where water would appear, which valleys would flood, and where vegetation would flourish. Predators followed these patterns, stalking their prey along the corridors of life created by the ever-changing climate. Floodplains, deserts, and forested coasts were all connected in a network of survival orchestrated by the invisible hand of the atmosphere. Even at night, the climate's effects were evident. The dry interior cooled rapidly after sunset, and nocturnal creatures emerged to exploit the brief respite from heat. Breezes whispered through the forests and deserts, carrying scents, spores, and stories of distant lands. Above, stars twinkled in a clear sky, yet every breeze reminded life that it existed within a dynamic, ever-moving system. The wind, storms, and climatic cycles were not background features, they were active participants in the shaping of life on Pangaea. Through these vast atmospheric processes, life learned resilience, adaptation, and connectivity. From coastal monsoons to interior dust storms, from volcanic eruptions to ephemeral rains, every element of the climate shaped behavior, evolution, and ecological balance. Organisms adapted to extremes, ecosystems evolved intricate interdependencies, and the supercontinent became a laboratory for life itself. The sky was alive with motion, energy, and influence of force as crucial to survival as rivers or mountains. In this section, we see how the atmosphere sculpted the Earth's surface and its living communities. Winds carried seeds and spores, storms replenished rivers and floodplains, and deserts tested the limits of endurance. Life responded with ingenuity, adapting not only to survive, but to thrive within the challenges of a dynamic, interconnected climate system. The narrative of Pangaea's skies reminds us that the planet's history is written, not only on its rocks and rivers, but also in the invisible currents of air that continue to shape life to this day. Life on Pangaea, though resilient, was never immune to catastrophe. The planet's history was punctuated by events so dramatic that they reshaped every ecosystem, altering the course of evolution itself. Among the most profound of these was the end Permian mass extinction, often referred to as the Great Dying, around 252 million years ago. A series of extraordinary volcanic eruptions in what is now Siberia transformed the Earth's atmosphere, oceans, and landscapes, triggering a cascade of environmental upheavals that would test the limits of survival. The Siberian Traps eruptions released immense volumes of lava, gas, and ash over hundreds of thousands of years. Sulfur dioxide darkened the skies, reflecting sunlight and cooling some regions, while greenhouse gases such as carbon dioxide trapped heat, sending others into scorching extremes. Oceans, once vibrant with life, became vast dead zones. Oxygen levels plummeted, suffocating marine organisms in a silent, invisible crisis. Coral reefs collapsed, and vast swathes of the seabed were stripped bare. On land, the effects were equally devastating. Rivers dried, forests wilted, and the deserts of Pangaea expanded far beyond their previous boundaries. Imagine standing at the edge of a once-lush floodplain. The trees are charred remnants, the riverbeds cracked and dry, and the air hangs thick with the acrid scent of ash and smoke. Herds of synapsids, once thriving along the rivers and forests, now struggle to find food and water. Amphibians vanish from wetlands, their calls silenced by the heat and drought. Insects, which had persisted for hundreds of millions of years, experience sudden collapses in population. Only the hardiest creatures, small, adaptable synapsids, drought-resistant reptiles, and resilient plants manage to survive in these harsh conditions. The extinction event did not occur uniformly. Some regions, shielded by geography or microclimates, offered temporary refuges. Coastal forests, nourished by oceanic moisture, provided sanctuary for amphibians and small vertebrates. Uplands and isolated river valleys harbored pockets of biodiversity, where resilient species clung to life. These refuges became critical incubators for evolutionary experimentation. The survivors, though few, carried within them the potential to repopulate the Earth and give rise to new lineages. As life struggled, evolution accelerated. Small synapsids, once minor players in the shadow of larger predators, diversified into new ecological roles. Their compact size, efficient metabolism, and adaptability became advantages in a world of scarcity. Insects evolved new forms to exploit niches left vacant by extinction, while early reptiles, freed from competition, spread into emerging habitats. Even plants played their part, with hardy conifers and drought-resistant seed ferns reclaiming disturbed landscapes. Nature's resilience was on full display, demonstrating that life adapts not only to thrive, but to endure the unimaginable. In the oceans, survival favored the flexible and the adaptable. Fish species capable of tolerating low oxygen levels persisted, as did certain invertebrates able to burrow into sediments or enter dormant stages. Over thousands of years, these survivors would form the foundation for a renewed marine ecosystem, gradually restoring balance as environmental conditions stabilized. On land, the new ecological order was marked by smaller organisms occupying niches that had once been dominated by giants. The absence of large predators allowed smaller species to flourish, diversify, and explore opportunities previously inaccessible. The extinction event also catalyzed evolutionary innovation. Reptiles, in particular, began to explore a staggering variety of forms and functions. Some became swift, agile hunters. Others bulked up into the first large herbivorous forms. It was during this era that the first true dinosaurs began their slow ascent. At this stage, they were small and inconspicuous, but the potential for dominance was already encoded in their lineage. Mammal-like synapsids, too, retained the traits that would later define mammals: efficient metabolism, warm-bloodedness, and adaptive behavior that allowed survival in fluctuating climates. The Great Dying left scars not only in species diversity, but also in ecosystems themselves. Ancient forests that had teemed with life became sparse, dotted with resilient plants capable of withstanding heat and drought. Floodplains and river valleys, once crowded with amphibians, synapsids, and insects, now hosted new assemblages of smaller, adaptable creatures. Desert interiors expanded, creating ecological laboratories where only the most resourceful survived. These changes reshaped the Earth's biotic landscape, setting the stage for the Mesozoic era, the age of dinosaurs, and the rise of mammals. The aftermath of extinction was a study in contrasts. Some regions slowly regenerated into lush forests, while others remained barren for millions of years. Rivers carved new channels through recovering landscapes, linking habitats and facilitating migration. Monsoon patterns, winds, and climatic cycles, altered by volcanic activity and continental configurations, further influenced the distribution and adaptation of species. Life, in its ceaseless drive, explored every available niche, repopulating the Earth in ways that were both predictable and surprising. In this delicate dance between catastrophe and survival, the evolutionary trajectory of Earth was irrevocably altered. Life became smaller, more adaptable, and increasingly specialized. The survivors were not the strongest or largest, but the most resilient. Their survival laid the groundwork for future ecosystems, shaping the paths of dinosaurs, mammals, and even plants that would dominate the landscapes of the Triassic and beyond. Every scar left by the Great Dying was simultaneously a seed for renewal, a reminder that extinction and evolution are two sides of the same process. Fossil evidence from this era speaks volumes. Sedimentary layers reveal sudden die-offs followed by periods of sparse but diverse recovery. Fossils of small synapsids and early reptiles dominate post-extinction deposits, while the absence of large amphibians and other giants marks the extent of the catastrophe. These silent witnesses capture the rhythm of survival and adaptation, illustrating how life responds to both environmental extremes and opportunities for diversification. The story of extinction is not one of finality, but of transformation. Pangaea's survivors carried forward the genetic legacy of pre-extinction species while innovating and diversifying in response to new challenges. Reptiles and synapsids ventured into niches left vacant, while plants colonized recovering soils and stabilized riverbanks. Ecological networks rebuilt slowly, yet with remarkable efficiency, demonstrating that life, even after unimaginable upheaval, persists, adapts, and flourishes. Even today, the echoes of these evolutionary shifts resonate in the anatomy, physiology, and genetic memory of modern life. Mammals owe their survival strategies and certain physiological traits to the synapsid lineages that endured the Permian-Triassic extinction. Dinosaurs, in all their future diversity, trace their origins to the first reptiles that thrived in the ecological vacuum left by the Great Dying. Pangaea, scarred but not defeated, became a laboratory of resilience and adaptation, shaping the evolutionary future of Earth for millions of years. The narrative of extinction and evolutionary innovation during this period is a testament to the interplay of chance, adaptation, and resilience. Catastrophe acted as both destroyer and creator, pruning the old and enabling the new. Every volcanic eruption, drought, and heatwave was a selective force, guiding the development of traits and behaviors that would define the next generation of life. From desolate riverbeds to recovering forests, the story of survival unfolded across the supercontinent, rich in drama, struggle, and triumph. This section emphasizes that extinction events are not mere historical footnotes. They are pivotal moments that redirect the course of life. The Permian-Triassic extinction reshaped the evolutionary landscape, favoring small, adaptable organisms over giants, setting in motion the diversification of reptiles and synapsids, and ultimately laying the foundations for the Mesozoic era. In understanding this period, we see not only the fragility of life, but also its enduring power to adapt, innovate, and flourish, no matter the odds. After the darkness of the Great Dying, Pangaea stood scarred yet ready for renewal. The devastation left behind barren landscapes, stripped forests, and dry riverbeds, but also vacant ecological niches that beckoned the survivors to explore, adapt, and thrive. Life, though humbled, was far from defeated. From these remnants rose a new chapter in Earth's story, one defined by experimentation, innovation, and the slow, deliberate rebuilding of ecosystems. The first stirrings of recovery were subtle. In the river valleys where water still lingered, hardy plants took root. Conifers, with their drought-resistant needles, reclaimed the uplands. Seed ferns and cycads spread across warmer regions, their roots binding the fragile soil and preventing erosion. Even the harsh interior deserts saw small patches of green appear, tiny oases where water collected after rare storms. These green patches acted as stepping stones for animals, guiding migration and dispersal across the supercontinent. In these recovering landscapes, small synapsids, the survivors of the extinction, began to diversify. They were agile, efficient, and resilient, perfectly suited to exploit the new world. Some evolved into insectivores, scurrying through undergrowth, consuming every available arthropod. Others developed new herbivorous strategies, browsing on low shrubs or foraging along riverbanks. Their small size was no longer a disadvantage. It allowed them to survive on limited resources, evade predators, and explore niches untouched by larger, extinct species. Reptiles, too, seized the moment. Freed from many of their previous competitors, they spread into every corner of the recovering landscape. Some became swift hunters, their long limbs and keen senses allowing them to chase down prey across open plains and dense forests alike. Others grew bulkier, filling herbivorous niches and turning into the first significant plant eaters of the Triassic period. Among them were the ancestors of dinosaurs, small, unremarkable in appearance, yet carrying the genetic potential to dominate future eras. The rivers and floodplains, once teeming with life before the extinction, gradually regained vitality. Seasonal floods brought nutrient-rich silt, nourishing plants and allowing green corridors to flourish along these waterways. Insects swarmed once more, their buzzing filling the air. Amphibians cautiously returned to the wetlands, exploiting the new aquatic niches left empty. Small predators, carefully avoiding larger threats, hunted along river edges, maintaining the delicate balance of the reborn ecosystems. In the oceans, life was undergoing a parallel renaissance. Certain fish species had survived the low oxygen conditions, and as oxygen levels gradually increased, they expanded their ranges. Coral-like organisms began to rebuild reefs in shallow waters, providing shelter for invertebrates and smaller fish. Mollusks and cephalopods diversified, repopulating niches abandoned during the extinction. Slowly, the oceans regained their former complexity, though the process took millions of years. The recovery of Pangaea was not uniform. Coastal regions, nurtured by moisture-laden winds from Panthalassa, regenerated quickly. Forests re-emerged along the shores, offering refuge to amphibians and early reptiles. Inland, the deserts remained harsh, limiting the spread of life and favoring only the hardiest species. These contrasts created diverse ecological pressures, accelerating evolutionary adaptation. Animals in arid interiors developed water-saving physiology, burrowing behaviors, and nocturnal habits, while those along coasts relied on abundant vegetation and plentiful prey. The Triassic world became a stage for evolutionary experimentation. Small synapsids began exploring new behaviors, such as burrowing or nocturnal foraging, enhancing their survival. Reptiles, with their tough skin and efficient lungs, colonized open plains and semi-arid regions, becoming early pioneers of dinosaurian diversity. Even plants evolved, adapting to changing climates and filling the niches left by extinct species. This period was not one of giants. It was a time when resilience, flexibility, and innovation defined survival. Rivers and waterways played a crucial role in this recovery. They acted as highways for migration, linking distant regions of the supercontinent. Species could move freely, colonizing new habitats, mixing gene pools, and testing novel survival strategies. Floodplains, with their fertile soils, became the lifeblood of terrestrial ecosystems, supporting dense plant growth and attracting herbivores. Predators followed, carefully navigating the landscape, and slowly, the intricate web of life reassembled itself. The skies, too, witnessed change. Birds were not yet present, but flying reptiles began to emerge later in the Triassic, hinting at a future dominated by aerial predators and explorers. For now, however, the air was filled with the calls of surviving amphibians, the buzzing of insects, and the subtle rustle of small synapsids moving through undergrowth. Even the wind and weather played their part, distributing seeds, pollens, and spores, influencing migration and shaping the habitats of the recovering world. Climate remained extreme, yet its variations acted as a catalyst for adaptation. Monsoons and seasonal rainfall brought life-giving water to some regions, while prolonged dry seasons tested endurance and resilience. This patchwork of environmental pressures ensured that no single species could dominate entirely. Instead, evolution favored those capable of responding to change, laying the foundation for the incredible diversity of life that would follow in the Mesozoic. Within this context, evolutionary lineages diversified rapidly. Some synapsids evolved into forms that resemble early mammals, displaying features such as more efficient jaws, differentiated teeth, and advanced sensory abilities. These small creatures, often overlooked, carried the potential to redefine the ecosystems of the future. Reptiles, meanwhile, began exploring forms that would eventually give rise to the earliest dinosaurs, both herbivorous and carnivorous, setting the stage for an era dominated by these iconic creatures. Plants, often the unsung heroes of recovery, stabilized the soil, enriched the environment with nutrients, and provided essential resources for herbivores. Conifers, cycads, and ferns spread across floodplains, hills, and coastal plains, ensuring a constant supply of food for the recovering fauna. Their roots prevented erosion, while fallen leaves and debris added richness to the soil, creating a feedback loop that supported further ecological regeneration. The interplay between survivors of extinction and recovering ecosystems was intricate. Predators relied on herbivores, which in turn depended on plants. Rivers connected regions, facilitating dispersal, and the wind carried spores and seeds across vast distances. These connections, subtle yet profound, illustrate how life rebuilt itself not in isolation, but as part of a vast, interconnected web of recovery. By the late Triassic, Pangaea was no longer defined solely by its scars, but by the promise of renewal. Rivers flowed steadily once more, forests regained density, and deserts, though still harsh, became zones of evolutionary experimentation. Life was smaller, resilient, and adaptive, but it was flourishing. The survivors of the Great Dying had not only endured, they had laid the foundation for an entirely new era. This recovery, though slow and measured, set the trajectory for millions of years of evolutionary experimentation. Dinosaurs, mammals, reptiles, and plants were now poised to explore new strategies, behaviors, and habitats. Every river valley, forest patch, and coastal plain became a crucible of adaptation, a proving ground where survival demanded both ingenuity and resilience. In reflecting on this period, one realizes that recovery is as essential to Earth's story as catastrophe. Extinction events prune the old, but they also enable the new. Life, in its persistence, demonstrates that from desolation comes opportunity, and from survival comes innovation. Pangaea's vast landscapes, scarred yet fertile, provided the stage for life's triumphant return, a testament to the enduring power of adaptation and the inexorable drive of evolution. The Earth itself, its rivers, mountains, deserts, and skies shaped and guided this recovery. Climate patterns, ocean currents, and geological activity influenced where life could thrive and where adaptation was necessary. Seasonal winds spread seeds and spores, floods created nutrient-rich corridors, and volcanic soils offered pockets of fertility. In every interaction between organism and environment, the story of recovery unfolded with poetic precision. As the last remnants of Pangaea's unified lands slowly drifted apart, a new world emerged, fragmented, diverse, and filled with possibilities. Oceans widened, mountains rose, and deserts expanded, creating a mosaic of environments where life would continue its relentless journey of adaptation and evolution. Yet, even in this division, the echo of Pangaea persisted, woven into the very fabric of Earth's geography, climate, and living beings, standing metaphorically on the shores of the newly forming continents. One could trace the invisible threads connecting past and present. Rivers that once flowed freely across the supercontinent now carved distinct paths through isolated lands. Species that had roamed together now faced separation, evolving independently into the myriad forms that populate our modern planet. Fossils buried in far-flung regions, separated by oceans, tell the story of a time when no sea stood between them, when life was free to roam a single, unbroken Earth. The climate, shaped by the positioning of these drifting continents, continued to influence evolution. Coastal regions retained moisture, nurturing lush forests that supported abundant ecosystems. Interior lands, left dry and harsh, became arenas of survival and innovation. Winds, monsoons, and ocean currents, once uniform across a single supercontinent, now varied regionally, creating localized climates and ecological pressures that drove the divergence of species. In every corner of the globe, life was learning to adapt to the new realities of a fractured Earth. Yet, Pangaea's legacy extended far beyond its immediate influence on life. Geological formations, mountain ranges, sedimentary deposits, and rift valleys carried the memory of ancient collisions, compressions, and separations. The Appalachian Mountains of North America, the Atlas Mountains of Africa, and the Scottish Highlands all share a common origin, remnants of the same chains that once soared together. Through rocks, sediments, and fossils, the story of Pangaea is written for those who seek to read it, a testament to the planet's dynamic history. The survivors of the great extinctions, small synapsids, reptiles, and hardy plants, had set the stage for the next great chapters in Earth's history. Dinosaurs rose to dominance, mammals slowly diversified, and plants colonized every available niche. Rivers, coastlines, and deserts became crucibles of innovation, influencing migration patterns, dietary adaptations, and reproductive strategies. Even in isolation, species carried traces of Pangaea's connected world, genetic memories that linked them back to the supercontinent's brief moment of unity. In reflecting upon this vast and intricate story, one begins to see the patterns of continuity and change. Pangaea was not just a landmass. It was a laboratory, a canvas, and a crucible. It demonstrated the interconnectedness of life, the resilience of ecosystems, and the profound influence of Earth's physical forces on biological evolution. Every extinct species, every surviving lineage, every shift in climate and geography contributed to the narrative of survival and adaptation. The ocean currents that now circle our planet, the monsoon patterns that nourish distant continents, and even the genetic blueprint within our own cells all bear traces of that ancient unity. Life's adaptability, its tenacity in the face of catastrophic change, and its relentless drive to explore and occupy every niche are lessons embedded in the legacy of Pangaea. From the smallest insect to the largest predator, from humble ferns to towering conifers, every organism participated in a story that began when all land was one, and continues to shape the world we inhabit today. To stand on any modern continent is, in a sense, to stand on Pangaea's shoulders. Every landscape carries fragments of its past, every river whispers of ancient courses, and every mountain echoes the collisions that once joined the continents. Fossils, rock strata, and climate patterns provide a continuous thread linking the distant past to the present, reminding us that Earth is not static but a dynamic, ever-changing system. Even as humans now traverse continents with ease, as airplanes and ships connect distant lands and ours, the memory of Pangaea underscores a fundamental truth, that Earth's life and land are profoundly interconnected. The evolutionary paths carved in the Triassic, the survival strategies honed after mass extinctions, and the dispersal patterns facilitated by unbroken land masses have all contributed to the biodiversity we witness today. Pangaea's legacy is not merely historical. It is alive in the genetic, ecological, and geological frameworks of our planet. The story of Pangaea, then, is both an ending and a beginning. Its breakup did not erase its impact. Rather, it multiplied opportunities for life to diversify, innovate, and explore new territories. As continents drifted, they created isolated laboratories where evolution experimented endlessly. Some species thrived and became dominant, others faded into extinction. Yet all contributed to the complex web of life that defines Earth today. And so, in contemplating Pangaea, one is invited to see beyond the map of continents, beyond the current arrangement of oceans, mountains, and deserts. One is invited to imagine the vast, unbroken supercontinent, with its rivers teeming with life, forests sheltering countless creatures, and deserts shaping resilient species. One is invited to listen to the voice of the ancient sky, the whisper of winds across plains, and the rush of water carving its eternal path. This is a story not just of land and life, but of persistence, adaptation, and interconnectedness. Pangaea teaches us that change is constant, yet within that change lies continuity. Life persists, adapts, and flourishes, drawing upon the legacy of what came before while shaping what is yet to come. The Earth, ever dynamic, continues to rewrite its story, and the imprint of Pangaea remains an enduring testament to the power of unity, diversity, and resilience, even now, as we walk across continents divided by oceans, as we study the fossils of ancient forests and deserts, and as we trace the winding rivers of our world. The echo of Pangaea resonates. It reminds us that life is not confined by borders, that ecosystems are interconnected, and that the Earth is a single, dynamic system in perpetual motion. The memory of Pangaea is a call to recognize the threads that link past, present, and future, to understand that our world has always been larger, stranger, and more connected than it appears. As the sun sets over modern continents, casting shadows over mountains and rivers, one can imagine the supercontinent in its prime and broken, alive and vibrant. Though it has vanished, Pangaea's spirit endures, flowing in the currents, rising in the winds, and thriving in the life it nurtured. It is a reminder that Earth's story is far from complete, and that the chapters yet to be written will continue to draw from the profound legacy of a world once whole. And so, we close the story of Pangaea not with finality, but with reverence. Its deserts, forests, rivers, and mountains, though scattered, continue to shape the planet. Its survivors, through countless generations, have ensured that life endures. Its lessons, embedded in rocks, fossils, and genes, remind us that resilience, adaptation, and interconnection are the hallmarks of existence. Pangaea is gone, yet its echo remains, a silent witness to the Earth's eternal rhythm, a testament to the enduring power of life, and a beacon guiding our understanding of the world we inhabit today.